Hi, my name is Massey and I'm an expert in Newton's first law.
Hi, my name is Masher and I am an expert in Newton's second law.
Hi, my name is Bilal and I'm in charge of Newton's third law.
Nice.
I'm an expert in Newton's first law, which states that when an object's at rest, it'll continue in rest. And when an object's in motion, it'll continue in motion, unless acted upon by an unbalanced external force, which is also known as the law of inertia. This suggests that when all forces are balanced, acceleration will equal to zero. The ball is currently in rest position, meaning that there are only two forces acting on the ball, and those are the normal and gravitational force. But both these forces are equal to each other, so they balance each other out. And not only is the velocity of the ball equal to zero, but the acceleration as well.
According to Newton's first law, we know that on a perfectly frictionless surface, the ball kicked will never slow down. However, in the real world, we do have elements such as air resistance as well as friction against the grass, which causes the ball to slow down. Newton's second law states that objects in motion have a net force which is equal to the object's mass times its acceleration.
I'm standing here 2 meters from that backpack over there. I'm going to go ahead and kick this ball with two different forces to show that the acceleration of this ball is dependent on the amount of force that I put on it. And we know this from Newton's second law.
As we can observe from the first clip, Bilal puts a small force on the ball, and thus the ball experiences a small acceleration and only goes a small distance. In the second clip, Bilal applies a much larger force, and thus the ball travels a larger distance and experiences a greater acceleration. Due to this, we can see that force and acceleration are proportional through Newton's second law.
Newton's third law states that every action has an opposite but an equal reaction. So I'm going to hit this ball at the crossbar and let's observe what happens. The way Newton's third law applies to this scenario is that when the ball hits the crossbar hits the ball with the same amount of force. This is evident by the ball moving back. Newton's third law states that every action has an equal but opposite reaction, and this is proven through this example.
As we have shown, Newton's three laws of motion can be identified in soccer in numerous ways. The stopping and slowing of a ball can be identified through Newton's first law of motion, the different forces that players kick the ball, and the different distances that the ball goes can be identified through Newton's second law, and finally, the ball hitting a player or hitting a crossbar can be identified through Newton's third law. Newton's laws can not only be applied to soccer, but to many other sports and many other activities in our society today, and that's what makes them so important.
No.